Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. Specifically, in this video, it's the first in a series of videos for configuring our system to mount and remount standard, encrypted, and network file systems. We're going to cover each of those types of file systems in a separate video, with this being the first, which will talk about encrypted file systems. We're not going to spend a bunch of time in how to use the fdisk utility or how to format partitions, since those are covered in detail in other videos. However, what we will be talking about is specifically how to mount, unmount, and mount them automatically, not only with boot, but so that we can use the mount utility without having to pass all the command line parameters in. The encrypted file system is a little bit different, so we're going to spend some time on how we set up a drive and create that encrypted partition, and then what we need to use it. So there's a couple of things that we have to do first. The first thing is we have to make sure that our system has been compiled to support encrypted file systems. And we can do that by running a quick command on one of our configuration files. So if we do a grep-i on the config, and let's type that right, the config underscore dm underscore crypt in the boot, and then config, and it's 2.6.5, but in this case let's make sure that we get the right exact information by doing a uname -r, and it'll tell us that config dm crypt was indeed compiled as a module into this kernel. So now what we need to do is we need to see if the module is indeed loaded, which we can do with an lsmod, and we grepped for dm underscore crypt. In this case, it does happen to be loaded. If it were not loaded, then what we would need to do is we would need to do a mod probe on dm underscore crypt, and then we would do an lsmod to make sure that it was loaded. In this case, it's already loaded, so we don't have to worry about it. Now we also need a utility in order to format and set up and use our partition, and we're going to use something called crypt setup. It's a front-end interface that allows us to create, access, configure, manage all those things for encrypted file systems using the dmcrypt kernel module. So let's go ahead and install that, and if you're using an Ubuntu system, you can use aptitude or apt-get. For CentOS, which is what we happen to be using, we're going to use yum. We're going to do a yum install on crypt setup, and this will just pull down that that file package and install it. In this case, it does happen to be installed, and you'll notice LUKS, and LUKS is the default operating mode for crypt setup, and it stands for the Linux Unified Key Setup. So that's what we'll go ahead and stick with here. It's the one that's most in use for encryption of hard drives. So the first thing we need to do is we need to pick a drive that we're going to encrypt. So let's take a look at what that would look like. Let's clear, and let's do an fdisk-l. And what this should tell us is what we have available on our system. It looks like we've got an 8 meg file system and a 19.3 gig file system, neither of which have partitions set up for them. So let's go ahead and do that first. Let's set up a partition. This is because these are drives that have no partitions on them yet. They have no operating system or formatting on them, so we're going to go ahead and set that up now. So let's do dev sdb, and we're going to do a new partition, a primary partition, number 1. We'll leave it for the defaults. We'll write it to the drive, and then we'll now do an fdisk on -l dev, and we'll see that SDB1 now has a Linux file system partition that we can use for encrypting our file system. So now what we need to do is we need to use crypt setup with the LUKS format to begin the setup process for this partition and the passphrase. So let's take a look at that. So if we do a crypt setup -y, and then we're going to say use the LUKS format on dev sdb1, then it will overwrite all data on the drive, which we're sure that we want. Type uppercase yes, so we need to say yes. We're going to enter a passphrase, verify the passphrase. This is what we're going to use when we access our partition. and we're using a relatively small drive. If you're using a large, one of the reasons we're using a relatively small drive is because if you're using a large drive, this could take a little bit of time to set up the encryption for. So now that we've got the encryption for that particular drive set up, all of the different commands that the different command types that we can use, the extensions for it, we're just using the default ciphers, hash, or key parameters, which we could change with dash cipher, dash hash, and dash key size. And that's listed in the proc file in, if we do a cat on crypto, not the dog from Krypton for Superman, it tells us what all of our defaults for our encryption for our drives are. In this case, we simply accepted the defaults for our encryption. So that's what we set up our encryption on that file system with. So now what we need to do is we need to open the partition, and that's when we'll be prompted for the passphrase that we entered earlier. So if we do a crypt setup, lux open, and then dev sdb1, and then what we're going to do is we're going to call the partition something. So we'll just call it my encryption. The passphrase is the one that we entered when we created it. And once the file system partition has been opened, then that file system is able to be formatted. And in our case, we'll go ahead and format it as an ext4 partition. Real quickly, mkfs-t ext4, and then dev sdb1. We're able to use the partition once we've opened it using the crypt setup application and the appropriate passphrase. So now we can use it as a regular drive. From within this, in this case, a virtual machine, we can do whatever we need to because this particular drive is now open for use. The only difference is we can't format dev sdb1 because that's actually the encrypted drive. We have to mount, or we have to format what's called the mapper. So the mapper is the overlay for this particular partition. So when we do an mkfs, -t on ext4, what we're actually going to be formatting is dev mapper, and the reason we gave it a name like my encryption is because now this will enable us to format that particular partition. So, and again, because this is a encrypted partition, you'll notice that any file system operation that we do is going to take longer than you would normally expect, especially considering that this is such a small file system, but that's because everything is operating within the encrypted kernel mode space. So let's go ahead and clear this. Now what we can do is we can create a mount point. We'll just call it ENC for encryption, or encrypt. That way we know exactly what it is. And then all we have to do is mount that mapper for my drive. So if we do a mount dev mapper my encryption, my encrypt rather, what do we call it? Dev mapper my encryption. So we'll do a mount dev mapper my encryption, and then mount enc encrypt. Now if we do a df-h, we should see dev mapper encryption is an 8 gig partition on the mount encrypt space. So at this point, we've mounted our file system, and we can use it, we can write files to it whenever we want. So now what we can do is we can do an unmount on the encryption partition. And then when we're done, we need to close the partition using crypt setup lux close my encryption. And this protects it. And this is where the protection comes in, because this protects it from being mounted outside of the unencryption process. So let's try this again. So let's remount this drive. After we open the partition by doing crypt setup lux open dev sdb1 my encryption, the passphrase during the creation, and now that partition is ready to be mounted with the mount command, and we can verify df-h. And then what we can do is let's go into the encryption, the encrypted partition, and let's do a encryption, and we'll create a file called encrypted content. And we'll look and we can see that that file has been created in cat encrypted content, and then it's encryption. Now what we do is we close the file by executing the close command, crypt setup, lux close my encryption, but let's drop out of the directory first. And then unmount the file system, so umount encrypt. Then let's close the drive. And now that the drive is unmounted and unclosed, then what we can do is we can test to make sure that our file system has been protected by trying to mount the partition by the drive letter. So if we do, for example, a mount dev sdb1 to the encryption directory, unknown file system crypto luks. So what we've done is we've created a file system that we can use and encrypt, but we have to open it using the crypt setup utility. We have to enter our passphrase, mount the file system using the mapper mount, do whatever we're going to do, then make sure that we unmount the drive, close the file system, and then that file system is protected by the password or the passphrase that we entered during the encryption process. So this allows us to mount, create and mount an encrypted file system on our Linux system. And again, this works whether it's a CentOS based or an Ubuntu based system. So for creating and configuring our system to mount an encrypted file system, that's all there is to it. My name is Terry for Linux Academy.